Okay, can you see my slides? Yes or no? Nampak tak?
Nampak.
Lambatnya jawab. Okay, thank you. So the slideshow you guys can see it, right? Okay, so kalau tak nampak bagi tahu. Okay, so hi everyone, Dr. Nat here. So we are continuing on lecture number 7. So this is on sectioning. So sectioning, we have not tried sectioning in AutoCAD yet. So this will be an interesting take to our engineering drawing. We will learn 3D models after this. And from 3D models, we will learn how to section the 3D models so we can see the inside of the 3D model that we built. So you guys have tried constructing isometric objects, but if you cut the object, you would not get the inside of the object because it's not technically it's not a 3D model. It's 2D that you have mapped together. Therefore, you get something that looks like a 3D, but it's actually not. If you rotate it, you would not get the other sides, right? So basically, an isometric drawing in AutoCAD is not the best way to represent a 3D, but it was important for you to understand how to do it as well for cases where you will be becoming a drafter later on after graduating. Okay, so for today's topics, we will cover on multi-view axonometric, oblique, and perspective projections. Just salah je, jap. Okay, never mind that one. Okay, so graphics communication with engineering drawing. So here I have an object, okay? And this object is drawn using orthographic projection, and I supply dimensioning so that you understand what is going on in the orthographic projection. Without dimensioning, you will basically have shapes and you would not know what the measurements are, and without scale, you would not know what the measurements are in real life. So when you supply that, you get a working drawing. And if the working drawing is clear, then your engineering drawing is finished. If it is not clear enough for the audience or the readers, then you would have to supply it with section views. So the diamond part of this flow chart is a yes or no. The output must be yes or no. And if it's a yes, you will finish. If it's a no, then you will have to supply with a section view to the working drawing. Okay, so this is just a basic flow diagram. You will learn how to use flow diagrams when you present your projects later. Okay, so the purpose of section view is to clarify the views by reducing or eliminating the hidden lines. And then you would reveal the cross-section shape. And it also facilitates the dimensioning because basically you get to see the inside of an object and therefore you would see the dimensions of the inside as well. So let's see an example. So the advantage of using a section view, I think someone is trying to enter the select yeah. Okay, so let's continue. So okay, it's an example. So an example, advantage of using a section view. So here is an example of a 3D object. Okay, so this is the top view. This is the top. So this is the front view from this side. And this is, this is the back. This is the back and this is the front. So this is the front whereby there's a hidden lines and this is the back. Well, technically you would choose the ones with the least, this is the top actually. Sorry. This is the top and this is the front. Sorry, my bad. So from the front is here and then you would have hidden lines because you are observing from here. Okay, so you have this hidden line and then you have this hidden line which indicates that there is an edge inside of the object, and then you have some structure going on here, and then when you view it from the top you would see that actually this structure is this guy. So if you extend your extension lines, you would observe that they have this similar dimension, and then this one correlates to this, and then this guy's edges is basically over here. Okay, so this is the top. Okay, so this seems straightforward, right? But if we supply with the section view, okay, basically we're cutting it like that, and then we would drag it out, and this is going to be your new front view, or for the section view for your object. And now the front view of this object is no longer hidden, so everything's visible lines now. Just now, okay, let's go back. Just now it was hidden lines, everything was hidden because it was closed. And then when we sectioned it, now we can see that these are all now visible lines. And another interesting part is that now we can hatch it. We've done hatching before in our assembly drawing, but you did not know what hatching actually meant. Now hatching is used for a section drawing whereby you cut, and it tells you that this is a solid and this is not a solid. Basically it's a, what do you call it, an open, what do you call it, kosong lah. What is kosong in English?
Empty, doctor.
Oh yeah, empty. Empty, okay? We'll use that word, empty. And this is a solid, and this is empty. So section tells us that without sectioning, you wouldn't know whether this is empty or it's like hollow-like, or if it's a solid. So because of this hatching, we know that it is a solid. Okay, moving on. So after you have sectioned the object, you would dimension it like so. So now it becomes more clear. Okay, terminology and common practices in section view. So we have the first one, which is cutting plane. The one that we saw just now is called cutting plane. So cutting plane is a plane that imaginarily cuts the object to reveal the internal features. Straightforward. So we have the similar object just now. So it's just basically cutting it and showing you that part. So whatever that is cut now becomes the, whatever is at the edge of this plane is now the new view. So these are section lines, and this is the cutting plane line. Okay, so cutting plane line is an edge view of the cutting plane. So another example, so this is from the front over here. Okay, so you have a hidden feature here and you have a hidden feature here. From the front you can't see it, and then from the top you have this hole and this square. So if you section this object like so, now you can see how the hole and the square actually looks like from the inside. So this is the typical symbol used to indicate a section. So this indicates the path of the cutting plane. Just now it was a straight line. Now this one is like a zigzag, or it's bent. Okay, so you see that there is slight thickness to where it's bent and thickness at the ends of this path. So this is important, and it tells me that this is a section view and you are viewing it from this side. We'll discuss more on that later. Okay, so I'm viewing it from here. Okay, so what I'm going to see is the inside of this hole and the inside of this square. Okay, so now it's no longer hidden, and you know that this is a solid, so you would hatch it. Cutting plane line style. So we have several types. This is the ANSI standard, or the American standard. So just now we saw a line with thickens. I can't actually draw right now. Let me try. Can I draw? I could draw. Kejap. Pen. Oh, boleh. Okay. Oops. Control Z. Oh, tak boleh Control Z. Okay, so just now we saw something like this, right? Which indicates our section view. But for the ANC standard, the section view is actually an arrow. Just now there was no arrow at all, and we have this dash lines, almost like a center line. And then we also have regular dash lines or uniform dash lines. And then we, for the ISO standard or the typical standard that we typically use, is slightly thickened, and the lines are like this. So please take note, when we are drawing, we will use this. This course will be using this type of section path. Okay, so there are several types. We will be using this one, whereby it's slightly thickened with no arrows. Okay, and the line is almost like center line. Okay, so section lines or cross-hatch lines are used to indicate the surfaces that are cut by the cutting plane and also tell us that they are solid instead of hollow. So we draw these section lines with thin lines. We know this already, we've done it before. The section lines are different for each material's type. For practical purpose, the cast iron symbol is used most often for any materials. So the one that we used in our assembly drawing was actually a typical cast iron symbol. So let's take a look at different types of materials. If you're using wood, if you're using cement, what would be the hatch, sorry. So this was the one that we used, and this is the default. If you don't know what the material is, you would use the default. If you know what it is, then you would use accordingly. Okay, so for wood, this is how it looks like. This is sand, concrete. Excuse me. And then we have steel. Okay, so for the hatch or the section lines, it can't just be any lines. So let's discuss on that. So section lining practice. Okay, give me a minute. I need to drink some water. Okay, so the spaces between the lines for your hatch may vary from 1.5 for a small section to 3 millimeter for a large section. For example, if your object is very small and your hatch line is 3, so it's going to be like that. So that's not ideal. So you would use a 1.5 millimeter instead. Oops, sorry. That's not how it should be drawn, like that. Okay, so it's going to appear more hatch, if that makes sense, compared to this. Okay, but if your object is big, like this guy over here, then you can use 3 millimeter distance between the lines. Now, what about the angle? We have not talked about the angles. In our assembly drawing, we just use whatever was the default, and if it was too small, I asked you to increase the size, right? Remember? So a common mistake with section lining practice, and you will need to know these things because you will have to submit a complete working drawing for your individual project later. So all these tips and practices and the convention you have to know if you are going to present your working drawing correctly. But of course, all the lectures are available. You just have to access them and use them. Okay, so a common mistake with section lining practice is too close together lines. We don't want that. Too far away. Non-uniform, because a non-uniform section line can indicate a different material. So that depends on the material now, and not exactly drawn perfectly. So they should be parallel to each other, like this one, and not converging. Okay. So it should not be drawn parallel or perpendicular to contour of the view. What does that mean? So here we have an object. So just by this sentence, I know that I'm not supposed to hatch like this because I should not have it parallel to the contour. If this is the way to do it, if this is the hatch, then this is going to be parallel to this contour, and this is not good. Or it should not be like this because this is perpendicular to the contour, which is also not great. So let's see. So you would hatch it like that, whereby it's not perpendicular and it's also not parallel to any contours in the object. Okay, so common mistakes is this guy is parallel to here, and this guy is perpendicular to that contour, and this guy is parallel to this. So these are not the way to hatch. It should not, it can be any angle as long as it's not parallel. Oh, my battery is dying. So it should not, apa tadi? It should not be perpendicular or parallel. Okay. Charger saya rosak ke? Okay. So treatment of hidden lines. Hidden lines are normally omitted from section views. So let's see. Oh, so one of the mistake that you guys did in isometric drawing was include hidden lines in your drawing. Now I understand that giving a lot of information is good, but sometimes that's not the convention. So same case over here. Section viewing, we typically omit it, and the best way to represent a section view is to not include the hidden lines. So let's see. So we have an object. This is from the top, and this is from this. No, it's from this side. Is it? It's from, macam tak berfungsi brain saya. It's from, oh, so okay, this guy. So it's from here. Okay. So one is top, and then the other one is from the right side, or you would call it front, whichever that you want to call it. So we can section this guy. Typically, we would section along something that looks hollow so that we can observe what is inside this hollow part. Okay, so that is the path to indicate this is where you're sectioning it. So you have to draw that, and then finally you would draw the section part. So just now we have the hidden lines here that indicates this edge and this edge. But when we are representing the section view, you would leave this hidden line, even though it's still there, because we are observing only what is on the edge of the cutting plane. Okay, so again, omit the hidden line, even though it's at the back, it's there, but for the section view, you are only interested at what's in front, or what is interfacing with the cutting plane. Okay. All right. Kinds of section. We talked about one type, which was the cutting plane, and we saw that it could be straight or it could be something like that. And typically, we go for hollow features so that we know exactly what is going on inside those hollow parts. So we have several kinds. The first one is full section. Second one is offset, and we have half, and then we have broken out. Then we have revolved section, and then we have removed section. So it doesn't matter which kind that you like. You can use whichever that you want, as long as you are representing the section view correctly. So the one that we have saw just now, the one that we have seen just now is full section. The one that we have seen in our previous labs is actually the broken out section, if you still remember. So remember that we had one component whereby we had to do spline, and then we hatched it, and then there was like a hollow structure that we tried to represent. Okay, I know I'm not drawing it correctly, but it was suddenly there. The hatch was suddenly there. And when we have the hatch, it means that you are actually sectioning it. But the type of section is not a clean cut, it's called a broken out section. Okay, but now you're only learning it now, right? Okay, full section view. The view is made by passing the straight cutting line completely through the part, which was what we saw just now. Excuse me. Okay, so straightforward across hollow features. Okay, and then you would indicate your path, and then you would draw without the hidden lines. This is a center line, so it's fine, but the hidden lines go. Okay, so the next one is offset section view. Before that, does anyone have any questions? Is everyone okay?
Okay, doktor.
Okay, doktor.
Okay, so hopefully you guys are not asleep. Okay, let's continue with the second one, the offset section view. So this is an interesting model. We have not drawn this type yet. The cutting plane is offset to include features that are not in straight line. It is possible for cutting plane to change directions. We have seen this to minimize on the number of sectional views required. Alamak, stop lah pula. Uh-oh. Okay. Right, so just now it was a straight line. That, and of course you have dashes. But for offset, you have a change in direction because you want to look at all the holes in the object, but the holes are not aligned like this. The holes are aligned like this. So what you do is you would section it like this. So this is what's happening here. Okay, so because of that, you can stick to one section view instead of two. So if you do not use offset, what you would do is you would do something like this. So you have two sections, which would take up space in your working drawing. Sometimes it's okay to do that. Sometimes you don't have the space, so you go for offset. Okay. So the view is made by passing the banded cutting plane completely through the part. Oh, okay. So here this guy is from the top. My pen is not working. And this is from this side. Yep. Excuse me. Okay. So because we have a lot of hollow features here, so we are cutting across here, we are cutting across here, and we are cutting across here, which means that we need to use offset section view like that. So now you get to draw whatever that the offset section is representing. So now you have everything is not hidden anymore, and you would see that inside these hollow features is nothing much. It's kind of boring, but we need to know because we need to represent the model accurately. Okay, so now it's no longer hidden, and you know which parts are solid, and you would use the hatch line. Okay. Moving on. So here, do not show the edge views of the cutting plane. What does that mean? Excuse me. Okay. Time for a new one. Okay. Okay, sorry about that. So here, what they're saying is we have this cutting plane, right? But it's bended, right? So when you bend it, you would have edges like this. So it's telling you, you don't have to tell the audience or the readers that you're actually bending the cutting plane. You don't have to tell that. You just represent whatever that is there. You only have to show this. This is sufficient. So you don't have to mess up your section view. Okay? Wow. This is a lot of chonting. Okay, half section view, the next one. We talked about cutting plane, the full section. We talked about offset, which means that it was banded. And then we're talking about half. So what does half mean? Okay, so a half section is a view of an object showing one half of the view in section. This is how it looks like. So instead of so it's half. Okay. So now what you're seeing in the section view is not um, two things, right? Oops, sorry. It's not two things like that. What you're seeing is one is hatch and the other not hatch. Ya Allah, taruh tulisan. The other is not hatch. So you're seeing this part and this part. I'm so sorry for my bad drawing today. Okay. Stuck lagi. Okay, give me a minute. I think there's something wrong because I'm experiencing delay in clicking. At 9:39, please come back. Okay, welcome back. Let's continue on our section view. Entire screen. Am I still recording? Yeah. Okay. Tutup yang ni. Tutup yang ni. Okay. Okie dokie. So continuing on half section view, hopefully now there's no more lag in my slides. Okay. So again, instead of cutting across, we're cutting only half of whatever that we typically cut. So it's kind of counterintuitive because the word is half, but what we're really seeing is quarter. So just something to think about and to remember. So what you're seeing is actually like this. One side is not section and the other side is section. Now you would only use this type of section view if you know that this object is symmetrical. If it's not symmetrical, then this half section view would not be suitable. So half sections are commonly used to show both the internal and outside view of the symmetrical objects, and we have seen that before. So this side is the outer and this side represents the inner. So this is the section. So here they indicate the section like so. So this is using the ANSI standard for section. So we will not be using this one. Ours would be the thickened line. Okay. So this is from the top view, from the top. So it's indicating the path of your section view, which is a quarter of this object. So the view is made by passing the cutting plane halfway through an object and then removing quarter of it. So again, another example, this looks fairly symmetrical. So you can represent one side as the outer and the other side to be sectioned. Okay, so you are cutting here, like this part over here. Okay, so this is the path and this is where you are viewing it. So one side is the outer side and the other side is going to be the section, and you would represent this in your drawing like so. Oops. Okay, so like that. So a center line is used to separate the section half from the unsectioned half of the view, like this. Hidden line is omitted in unsectioned view, omitted in the unsectioned half of the view. So what you're seeing is if there is a hidden view, which is this hole, it's not represented. Because again, if this is a section view, even though it's half section, the hidden lines are omitted, but the center line stays. So broken out section view, the one that we've done before, using spline. It is common practice to section a part of the object when only small areas need to be sectioned. So you don't have to use half or you don't have to use full. Instead, you just want only a small chunk to be sectioned. So let's take a look. The example shows a broken out section view to indicate a through hole in a plate, like that. So we've seen this before, right? We've done it using spline and then we hashed it. So this is especially important if you have like screws coming. How do you draw a screw? This does not look like a screw. Okay, abaikan screw ni dulu. Okay, so this is something you'll be inserting something inside. If it's already assembled, if it's not, it's going to be hollow. But this is where you would use broken out section view to section small features like this. Okay, so the view is made by passing the cutting plane normal to viewing direction and removing the portion of object in front of it. So what does that mean? Okay, like this, we have the top view and also from the side, from the right or from the front, whichever. Okay, so this is symmetrical. So only one side, and then you would use, this is like analogy, like breaking it using a hammer, and then you would take out the part like so, and then you're left with the section view. So now you represent that in here. This is where you're viewing it. So one side is section, the other is outer. So whatever hidden line is now completely removed. So let's see if it's actually removed or not. Patut remove Hidden lines should not be there. So I forgot to remove this. So it's not supposed to be there. No hidden lines. Okay, so I managed to write nicely. Okay, so next one. A break line is used to separate the section view, the section portion from the unsectioned portion. So break line is a thin continuous line, 0.25, and is drawn freehand. It means in AutoCAD to use spline. Obviously, you're not using your freehand. There is no cutting plane line. Okay, there's no cutting plane line. Oops. Example, comparison among several section techniques that we've talked about. We have full, we have half, what else? We have offset, and then we have broken. Let's see. So this is the original guy, and this is full. You'll see everything inside, no hidden lines. And then we have half, whereby instead of going all the way, you would only go halfway. So what you're seeing is one section and the other part not section. Hidden lines are omitted. Every time you section, you would indicate with the path, like this guy. Okay? And then the last one that we talked about just now is the broken, whereby we used a hammer and broke the part that we wanted to see for no reason at all. We could just have used the half one, but it's okay. Contributes to art. So what we're seeing is only a slight part where it was broken. Okay. So again, how do we indicate? Um, yeah, okay, you guys can refer to the lecture later. Okay, so three types. Full, offset, four types actually. Full, offset, whereby we had the bend like that. Okay. So if you guys still remember, full, offset, half, and then broken. And then the final two is revolved section view. Okay, so this is a pencil. I believe so. So this is where you're viewing it. And then we want to know what is inside this pencil. And then you have a center line to indicate that it is cylindrical. This part does not have center line because it's not cylindrical. Okay, and then you would cut at some part. And then you would revolve this section like so. Then you would stitch it back. Basically, you want to see what's inside, but you are representing it outside of the object because you can't see it. Well, you just want to see this part. So it's just a type. So revolve section view. Sometimes you need it, sometimes you don't. Okay. So here it is overlapping the front view. It's overlapping. So the revolve section view is kind of messy because you have your object and then you have the section view on the object as well, overlapping. So another one, this is another object. This is from the top. Sorry, this is from the top. And sorry, and then this is from the front. Okay, top and then front. So step one, assign position of cutting plane. 2, draw axis of rotation in front view. So let's see again how it's done. So you have your cutting plane like just now. So you indicate where the cutting plane is, and then you would revolve that section to be overlapping your front view. So let's see. Transfer the depth dimension to the front view. Like that. So the final picture is a section view overlapping the front view. Personally, I don't like this type of section view, but if this is what you like, go ahead because it's not wrong. Okay, next one, placement of revolved section. So again, with the pencil, superimpose to orthographic view. Superimpose or overlapping. So another one, we have two section views here. So one is superimpose or overlapping the object or the front view, and then another one is break. So you would use spline to indicate, hey, this is where we are actually observing the section view and we don't want to overlap it. Therefore, we are breaking it and then portraying what's inside by putting it in the break part, which which is kind of weird, but it's okay. It's there for a reason. And then we have remove section view. Okay, I'm just going to go through these quickly because we're almost out of time. Okay, so again, we have the revolve section. One is superimposed or overlapping. The other one is break. This would have been a good MCQ question, but I did not manage to cover this topic. So you guys were safe. So next one is remove section, like that. So you would actually not superimpose or break the object, which is better in my opinion. Okay, so I like this one better. So if you're gonna submit something, submit it like this, not the overlapping or the break. I don't like this type. It's very messy and it doesn't give me a clear view of how the front view looks like because now it's broken up. Okay, so remove the section. Other examples. So basically it's just revolve, but you would move it outside of the front view like that. So this is the preferred way. Okay, again, another one. So when you have this path to indicate your section, typically people would label it as A to A. So section A to A is, this is how it looks like. So if you have another section, for example, from here to here, and then you would call this B to B, and then I would write in my note in my working drawing section B to B, which means that whatever that is between B to B is going to be my section. So whatever that is, so I don't know. Okay, something like that. Okay. Oh, ada B to B, sorry. Okay, so this is the convention on how to note your section line or your section pathway. If you only have one, then you don't have to label A to A or B to B. If you have multiple section views, then it is wise to label them A to A, B to B, or C to C. Sometimes you can use one to one, but one to one is not very helpful. So you would typically use letters instead of numbers. Okay. Okay, that's it for today. Any questions before I end class? Was it clear? Any questions on any parts? No?
No, Doctor.
Okay, so have a great day. I will see you guys tomorrow and we'll talk about your exam papers. Okay? So take care, everyone. Bye bye.
Thank you, Doctor.
Thank you, doctor.
Thank you, Dot.
Bye.
Bye, Doctor.
Bye. See you guys tomorrow. Stop presenting. Recording.